Hi, I'm Alex Paulton. I'd like to welcome you to another on-the-road episode of Talking Timepieces, where we talk about watch collecting and horology. Just checking to make sure the mic's on. Normally, in my day job, I don't have that many opportunities to talk about watches, but I bumped into Derek here, and not only is NXP talking about various technologies for personal devices, they're talking about watches, but then again, smartwatches are personal devices, aren't they, Derek? Thanks for doing this.
Yeah, my pleasure. Thank you.
Well, power reserve, ironically, is something that they talk about a lot in mechanical watches. It's interesting to see that power, of course, obviously is a concern with electronic.
Yeah, definitely. No one wants to be charging their watch, twice a day or whatever. So we're working hard to optimize your battery life, extend it, and we have wearables using our devices today that go 30, 40 days between battery charges.
Really? So now, the first answer, of course, is like duty cycle. I shut the machine down when I don't need it. I turn it on when I need it. Right. But I think this goes far beyond that, correct?
Yeah, we have a lot of hardware techniques in this chip, and we're leveraging it in some of the Zephyr software that we're demoing here. But yeah, for example, we have a GPU on here that's able to accelerate the rendering of the graphics that helps you get back to sleep faster, and you save power that way. So with our smartwatch demo, we have multiple screens that you would find on a smartwatch you would go buy. And these also help us demonstrate different power optimization techniques. The watch screens here, we have both digital and an analog screen. And these show ultra low power mode going into deep sleep mode. So they just wake up once a second, render the new screen, and go back to sleep. This is leveraging our GPU here. So the watch hands, as they change angles, that's all being calculated by the GPU to get back to sleep faster. So some of the techniques that we use to optimize power is showcasing how to get back into that deep sleep mode as fast as possible and reduce the voltage and the current consumption when you're in that mode. Some of the other screens we have that are more actively animating, like this EKG screen, because of the higher frame rate, they are rendering most of the time, so they are not in deep sleep as often. And on these screens, we're showing how we can better optimize power while in active modes. So we're using that PVT sensor here to minimize the voltage to achieve this performance, as well as some SRAM techniques that we're doing to reduce power consumption of RAM that you're not using at the time.
So it renders the graphics faster so it can go to sleep faster. It goes to sleep faster to begin with. Does it sleep deeper than other systems?
Yes, it does. It has several levels of sleep modes that you can use depending on what you're trying to do at that time. So if you need to stay awake while you're animating, you can reduce some power. But if you go into like a watch mode where you only update once a second, you can drop the voltage down to 600 millivolts while it's in a static mode, which drastically saves power. And we're talking like microamps of current at that point.
Now, is this something that the user would recognize, or is this just an incremental advantage at the embedded level?
The user will see it in the minimizing the time between battery charges. But from the developer, they get a lot of knobs that they can turn using our tools and our silicon, so they can optimize it for their use case. So some people are using this in like eyeglasses, and some are in watches, and some are in medical devices. And depending on what they need to do, if they're displaying or they're not displaying or they're talking to Bluetooth, they can turn the knobs to optimize everything that will optimize the battery life in their application.
Very cool, Derek. Thank you so much for taking the time to talk to me at this event, especially for something a little off-piste.
My pleasure. It's a pleasure meeting you.
Me too. Thanks.
Our smartwatch demo has a couple of different screens like you would find on a actual wearable device. And these also showcase some of the different features that we're... Uh-oh.
You know what, what I'll do is let me start with the whole thing and I'll zoom in on the screen and then that way you can just talk about it.
Okay.
Okay, you ready?
Not yet.
Okay.
Let me reset this.
Okay, so then...
Okay.
Oh,